Hey everyone. So today we are going to discuss about discount rates. The process of discounting basically refer to finding present value of future cash flows. The idea comes from the money. Present value of money is always going to be greater than the future um, money in the future. So when you take the if you have money in future and when you discount back it to present value, it should be less than what you see in the present in the future. For example, let's say this is present, and then this is future, and then if you have $100 here, and then when you discount it to the present, it should be less than $100. So it can be something like 90, 95, or maybe 80, depending on what kind of discount rate you use. So here we are going to discuss about discount rates. Okay. Later we are going to talk about discount factor using interest rate. In here we are going to talk about discount rate, okay, not the interest rate, but you can really discuss about discounting. The word discounting using interest rate. There is a relationship. Actually, we are going to learn about that in this slide, in this lecture too. Okay, so in previous setting, interest paid at the end of the time period. So however, sometime we want to we may demand interest must be paid by the borrower in advance before the borrow money become available. So when this happen, we use discount rate. So how we define discount rate? So here is the formula. So you take the discount rate between in time interval T1 T2 is defined as accumulation function value at time 2 minus accumulation function at T1 over 8 T2. So this may be not clear. So let's multiply and see what that means. When you multiply this one, you get 82 time discount rate for that time interval. So you can bring this one to other side and this one to this side. So you get 81, 82, subtract 82 times D1, D2. And you can take the common factor. So now you can see what I mentioned earlier. So here you can see that this is basically present value because time T1. So you have time, if you draw the time interval, this is T1 and this is T2. And here is the accumulation value at T1. Here is the accumulated value at time T2. And basically, when you multiply by this factor, 1 minus D time discount rate in time T1, T2, you get the present value. So basically, you are discounting. You are finding present value of future cash flow. You see this rate. So this rate is called as discount rate. Now you can replace this entire expression using interest rate. Okay. Later we will do that. Okay. So right now you can see, you can write the formula T1, 1 minus T1. Now if your discount rate is fixed over time interval, you can just write this as 1 minus D. Okay, assuming that discount rate is fixed. You can, in a way, like if you want to use present value future value notation, you can write present value equal future value times 1 minus D. Okay. So that's another way to see this equation. Now remember earlier with interest rate, what we wrote it future value equal present value times 1 plus either IT. IPI is in simple interest rate model. Future value equal present value times 1 plus IT. If you are using compound interest rate model. So in this case, you are looking how money going to be grown. to the at time t. So in this setup, you are looking at what is the real present value of future cash flow using discount. That's a keyword using discount. This is discount. Um, so here you can find you can see a question. A loan of 1,200 is made for 1 year at an effective rate of discount of 5%. You can also define effective rate of discount similar to effective rate of interest. What is the effective rate of discount for given time interval? Okay. What is the amount of discount? So we can calculate the amount of discount. So you can see you can loan of 1 year. So future value is future value is 1,200 and discount is 5%. So present value. So I can calculate the present value. Is going to be 1,200 times 0.95. That would be use your calculator. I'm going to use my calculator and get the answer 1,200 times 0.95. That would be 1140. So I want to know the amount of discount. So that's the difference between those two values. So amount of discount, that's going to be 1,200 minus 1140. And it is going to be $60. How much money available for the borrower at the beginning of the year? So basically 1140. How much money borrower will pay at the end of the year? That's 1,200. So in this case, you need to remember that 1,200 is what you pay at the end. Since discounting, you are really only going to get the 1140 from the lender, and you will pay 1,200 at the end. So here there's another question. What is the discount rate? So basically it says was 149. So now 99. Okay, so basically they know. You can write the present value is 99. Future value is 1140. 749. Yeah, so we need $50 difference. So 749. So you can calculate the discount rate. So present value is future value time 1 minus D. So 99 equal 149 and minus D. You can solve for D, basically 99 divided by 149. Let's solve for D. Let's see what's going to be the So it's 33%. Here's another question. What is the difference between the following two situations? A loan of 100 is made for 1 year at an effective rate of interest. So let's draw the timeline. So here is time 0 and this time 1. So here you get the $100. And then how much you need to pay in future? That's going to be present value term 1 plus I. Regardless which model you use, simple or compound, it's always going to be that, okay, because it's 1 year. Because the effective rate is for 1 year. So this would end up as 100 times 1.05. You have to pay $105. This is under interest. So when they state loan of $100 is made for 1 year at effective rate of discount, the 100 is actually what you pay at the end. Okay, so that's the difference between discount and interest. So here is t equals 0, t equals 1. So here you get $100. So you basically have to calculate what would be the present value. So present value is future value times 1 minus b, which is 100 times 1 minus 0.05. It is going to be 95. So what's the difference? Under first situation, under interest rate, you have $100 in your hand. So if you need $100 to start your project, then you have $100. Now, if you borrow money on a discount rate, now you don't have $100. Instead, you have only 95. But you don't have to pay 105. You can pay only $100. So there's a difference between the interest and discount and the wording. So you have to be careful. So here you can see the connection between interest and discount. So basically, what's going to happen if I draw a timeline here? Let's say, so then the rate would be IN. Okay. So let's say you have $1 here. Then under interest rate, it's going to grow into 1 time 1 plus IN. It is 1 plus IN. Now, if I want to discount back it to the same value, I have to use 1 minus discount rate, effective rate for that time period, effective discount rate. So when I multiply those two terms, 1 plus IN, 1 minus IN should be 1. So that's the first formula. So right away you can see, you can write IN using DN, DN using IN. So you get these two expressions. So suppose that an account is governed by compound interest at annual rate of 8%, find an equivalent discount rate D. So you can write the formula. So what's D? You'll see in this second formula, which is going to be IN over 1 plus IN, which is 0.08 over 1.0. You can simplify and make that. In this one, the process of computing the present value is called as discounting. Therefore, the present value is sometimes referred as discount value. So here you can see that the wording, what discounting means. The process of computing the present value. That's what discounting really means. The students sometimes really struggle to understand what discounting means. Discounting means basically you are trying to find the present value of a cash flow, future cash flow. It's always going to be less than the future value. So this is called as the so because of that, present value is sometimes called as discounted value. So you have two approaches. You can use either discount rate. If you do that, your present value is going to be future value times 1 minus D, or we can say N for that time period, N time period. So then you can use this formula, which we proved earlier. From here, I can see 1 minus D, basically 1 over 1 plus N. I can replace that in here, and I can get another formula. The present value is future value divided by 1 plus. So you have two approaches. You can either use discount rate. If you use discount rate, this is the formula, or you can use interest rate to discount. Then you get this second equation. So when discounting is there, we can define the discount function. Okay? So we had accumulation function. So let's go back to the original formula. At very beginning, we defined something look like this: future value equal present value times accumulation function. So this is accumulation. Before we come up with this formula for 1 plus IT, before all of that, the original formula was this one. So from here, you can rewrite it to look like present value equal 1. Future value divided by 80. You divide both sides by 80 and you get this. So I changed the side of it. So this one is basically we are trying to find the present value. Okay. So the process called as discounting. This process called as discounting. So then you can write it like that and then define this to be VT. So basically you can say present value is equal future value times some function. Then this function, instead of accumulation function, here we call accumulation function, this one we call a discount function. So it can take any form. Remember, accumulation function can have these two types of forms. I mean, the popular ones. So the same way you can define equations, specific function for VT, and then you get different types of discount process. Of course, you can see that right away the relationship between AT and VT is this one. Of course, if I define VT equal 1 over AT, and then of course multiply, you would get that's how that's what actually hidden in this formula. In this case, this is your AT, I mean AN, this is your DN. Or you can say VN, discounting. So sometime what's going to happen, we can specifically define what's VT. So remember, AT can be linear. When AT is linear, so this is accumulation function. So AT is linear. So how we define that? 1 plus R. So the model get a name. It's called the simple interest rate model. Sometime you can define AT is 1 plus I to the power T. Then the model become compound interest. Now the same way you can define discount function. Basically VT. So let's say VT is linear. So VT equal 1 minus dt. So basically this is saying linear. So this one linear. Linear. So this one called a simple discount model. And so when you have this, you can see right away the formula. Present value equal future value by dt. That's the original one. Then you can substitute this specific formula. From here, so since this is your VT, you can come up with AT, other kind of AT. So AT is 1 over VT because AT times VT is 1. So that's a different one. So here you have 1 plus IT, 1 plus IT, and then here you have 1 minus 2 using discount. So this discount, simple discount, used in US Treasury bill. The price of T will calculate using simple discount and 360 days per year. Okay, so I'm going to leave this one. Try it. If you cannot do it, send me an email. I will explain it to you the process. So I want you to try this one. Okay, so earlier we defined simple discount. Okay, so the word was simple. Now we want to define compound discount. So how we define compound discount? We define the discounting function to be 1 minus d to the power t. So remember that 1 minus d times 1 plus I equal 1. So now I can replace 1 minus d using 1 over 1 plus I, or 1 plus I to the power negative 1. So this function, you can even write using interest rate. So this is simple, this is compound discount. Become 1 plus I negative 1 to the power t. Basically 1 plus I to the power negative t. So, so this give So same function, but wrote using two different types of rate. Here I am using discount rate. Here I'm using interest rate. But the same discount function, the same. So then I can write the accumulation function, which is basically 1 over 1 plus 1 over Vt. Is going to be 1 over 1 plus I to the power negative t, which is 1 plus I to the t. So it turned out compound discount function is basically related to the compound interest rate model. Okay, so compound discount, compound interest, they are basically related. So you can right away write you can right away say that Vt times At equal 1. Vt is 1 minus d to the t and 1 plus I to the t. So sometime v is not change with time. So we can define v as 1 over 1 plus I. Okay, so here you can see if I take this particular one, we can write what Vt equal 1 over 1 plus I to the t. It's look like 1 over 1 plus I to the power t. So then this inside that's defined as v. So it's called as discount factor. Okay, so when you hear the word discount factor, it's not really discount function. It is just this term 1 over 1 plus I. In a discount function, it can be anything. Okay? It can be compound discount function. It can be simple discount function. If it's compound discount function, then it's look like 1 plus I to the power negative t. If it is simple discount function, it's look like what? 1 minus dt. So it's depend on the function. But discount factor always 1 over 1 plus I. So you can define few formulas. A discount is d equal I time v. How do we get that? You know that 1 plus I time 1 minus d equal 1. Then 1 minus d equal 1 over 1 plus I, which we define as discount factor. So same. So I get 1 minus d equal b. So that's basically then d equal 1 minus 2. So next, I can multiply I time v and see what am I going to get. I time v basically I v is 1 over 1 plus I. So that's going to be I over 1 plus I. And earlier we proved that this is to be d. We come here. I over 1 plus I is d. So you can use that formula back here, and then you can say this is d. That's how you get the first. And also you can write these formulas by replacing 1 minus d to the power of 2 by 1 plus 2. So here you can see some questions. This one asking what is the present value of $200 to be paid in 4 years, assuming money grow by compound interest at an annual rate of 6%. So what is the present value? So we want to find the present value. If I draw the time line, so here is 0, this is 4. So 2000. Now I want to know the present value. So rate is given using interest rate. So I would write present value time, future value time, v to the t. But it's compound interest. So basically 2000 time 1 plus I to the 4. And you can get the present value. So remember, under compound interest rate model, compound discount and compound interest, they are connected. So basically, this is going to be 1 over 1 plus I to the t. this term, V discount function. Here's another question. Suppose you have choice of borrowing at an annual effective rate of 5.1 or at an annual effective discount rate of 4.9. Which rate should we use? So basically, you need to have it in either an effective rate, annual interest rate or annual effective discount rate. So you can't have two different. You can't compare apple and orange. You need to turn everything into one term. So I'm going to convert discount rate to interest rate. So number one is given as annual effective rate, interest rate is 5. So for the second one, I need to convert. Okay, so how do I convert? We just have the equation here. D equal I times V, D equal 1 minus V, or D equal I over 1 plus I. So one of those forms. So I have D equal. Let me write the IUs in D. If you go to the earlier equations, you can see I equal D over 1 minus D. Sorry, I'm going to use that. So I equal D over 1 minus D, and D is given as 4.9. So for the second setup, what's the effective rate? This is a calculator. So I'm using a calculator. And you would get 0.0515. This is decimal, so it's 5.152. So of course you are going to use this way. Versus you are going to use the first one because you are going to borrow. You want to borrow at lower rate. Lower rate. If you are lending, then you use the first one, second one, because you won't lend at higher rate. But if you are borrowing, you need to use the lower rate, which is going to be the first one, not the second one. Second one is higher rate than the first one. Similar to nominal rate of interest, you have nominal rate of discount. So here you can see that the nominal discount rate convertible M times per year given by dm. Remember, for interest is IM. What is this? This is nominal rate of interest. Convertible M time per year. What that mean? That means basically you divide year to M time, M sub intervals. Then for this one small interval, effective rate. So 1 over M time interval is IM divided by M. Okay, that's what that means. Okay, for small subinterval, the effective rate. Then for the entire time interval, this unit time interval, nominal rate is IM. Okay, that's what that means. Just refresh your memory from last lesson. Now, the same way we have DM. What is DM? A nominal discount rate. Convertible M time per year. So same to the interest rate, what this means, you have unit time interval and then discounting done M time per year. So then for the small time interval, effective discount is dm divide m. So the whole time and the whole this unit time interval, nominal, not defective, nominal rate is. So then how do you get the effective discount rate for entire time interval? So the question would be effective rate for entire time is D. So here is the equation. It's going to be 1 minus D equal 1 minus D M. So M to be M. So next we can use one of those formula we learned earlier. We know that if we have effective rate, then 1 plus I time 1 minus D equal 1. And we also know that 1 plus I effective rate is 1 plus I M over M to be. Let's use N. N. And then we just learn 1 minus D, you can write like this way. So you can substitute those and you can get this nice second equation. So this question asks you find the effective annual discount rate for nominal rate of 6% converted quarterly. Nominal discount rate. So how do you do that? 1 minus D equal 1 minus dm. In this case, it's d4. So I can write 1 minus d equal 1 minus 0.06. And so let's simplify this. This is 0.985. Then you can make it, you can write d is 1 minus 1. You get 0.0586. So next one asks find the nominal discount rate convertible semi-annually corresponding to the annual effective discount rate of 8%. So you go the other way. So now you have the D to be 8%. So 1 minus P equal. They're asking I2, D2, because it's semi-annual. So 1 minus. It's made 1 minus 0.08. From here you can see 0.12. You can take the square root of both sides. And then now bring the terms. So one term to left, some term right, and then this is a calculator. P to be 0.08. Next one asking find the rate of discount convertible semi-annually that is equivalent to nominal rate of discount 10% convertible monthly. So we are using we are going to use this last equation, this equation for that. Okay. I will write the formula, then you can apply. So convertible semi-annual. So that means D. And then the other one is nominal rate of interest, 10% converted monthly. So this is basically I12. 1 plus. That's 20 equal to 1. That's the formula. This side is 1. So now I12 is given, which is 0.1. 10%. So you can solve for D2. Because that's the only unknown. You have one equation, one unknown, we should be able to solve for D2. Okay, so here you can see one of exam FM question. Now let's try to do it. It says Jeff deposit 10 into fund today and 15 years later. So times 0, times 15. So now $10, 15 is $20. Interest is credited at nominal discount rate of D compound quarterly for the first 10 years. We have somewhere here again. So that we are using nominal discount rate of D compounded quarterly for first 10 years. So if you use our notation, it's D4, okay? So this is D4. They use D, but you can say it's D4. Then and at a nominal rate of 6 semi-annually thereafter. So then we have I2. So this the accumulated value of fund at the end of 30 years is 100. So after 30 years, it's 100. We need to calculate D. And in our notation, it's D4. So let's try to calculate what would be the future value of $10. So it's going to be 10 times 1 minus 24 over 4 to the 4 times time. For 10 years, 10. Then at this point, you have another 20 years to go under interest rate. So it's 1 plus I2 over 2. 2 times how many years? You have 20 years. So that's the future value of $10. Then the future value of $15. So right away you have only 15 years. $10. The rate is nominal interest rate, 1% annual. So 2 times. So when you add these two, that should give you $100. Future value 1 plus future value 2. Again, the rates, some rates are given. This one is given as 6%. This is what you want to find. Okay, so only one unknown and one equation. So okay, so that's all for this lesson. And in next lesson, we are going to discuss about force of interest. I'm going to skip this problem. You can try it to do it. If you don't know how to do it, okay.